Hi everyone, in this video we'll look at dividing rational expressions. So first let's think about the rules for dividing fractions. Well, if I have a over b divided by c over d, well, division by a fraction is the same thing as multiplication by its reciprocal. So a over b divided by c over d is equal to a over b times d over c. And after I multiply by the reciprocal, I can just follow our standard rules for multiplying fractions, where this is going to be equivalent to the product of the numerators, which is AD, divided by the product of the denominators, which is BC. So A over B times D over C is equal to AD over BC. Now, one thing to note here is that B cannot be equal to 0, because if B is equal to 0, I have division by 0, which is either undefined or indeterminate. If d is equal to 0, I have division by 0 again, which is undefined or indeterminate. And if c is equal to 0, again, I have division by 0, which is undefined or indeterminate. So we have the restrictions that b, c, and d here cannot be equal to 0. None of those values can be equivalent to 0. Otherwise, I have fractions that are either indeterminate or undefined. I wrote out some steps for dividing by rational expressions. So the first thing that you're going to do is you're going to factor the numerator and denominator. Then you're going to state any restrictions that come up on the variables. You can then take the reciprocal of the divisor and multiply by that reciprocal, and that's the same thing as division. After this step, you're going to state any new restrictions that arise, and then you're just going to follow the regular steps for multiplication of rational expressions. So let's look at a couple of examples, the best way to learn how to do this. In this example, it says simplify and state any restrictions. So here I've got negative 20t over 3 divided by 4t cubed over 12. Well, if I look at this, I can change division by this fraction to multiplication by the reciprocal. So I've got minus 20t over 3 times 4t cubed over, oh, whoops, I have to multiply by the reciprocal. I was just multiplying by the same fraction. So I've got times 12 over 4t cubed. In the first step, I should have checked whether there's any restrictions from the denominators. And in the denominators, I've got 3 and 12, which don't have any restrictions on my variables. When I multiply by the reciprocal, notice that I've got a factor of t, 3 factors of t in the denominator. So I have the restriction that t cannot be equal to 0. Now I can go ahead and do some simplifying. Notice that in the denominator I have 3 times 4, which is 12, so I have a factor of 12 both in the numerator and in the denominator, which will divide out. I have 3 factors of t in the denominator, 1 factor of t in the numerator, so I can divide out 1 factor of t. In the denominator I'll have 2 factors of t, in the numerator I'll have 0 factors of t. Now we can go ahead and multiply the numerators. And if I do that, I get minus 20 over t squared. And I have to write out my restriction that t cannot be equal to 0. Example B is a little bit more involved. And in example B, the first thing that I'm going to do is I'm going to factor everything. So let's factor the numerator here. I've got 2x squared minus 5x minus 12. And I can factor it by using guess and check. 2x times x is going to give me x squared. I need 2 values that multiply to negative 4, or sorry, multiply to negative 12. Let's try let's try positive 4 and minus 3. And then let's check the middle term. Well, the middle term is going to be 2x times 4, which is 8x. 8x minus 3x is positive 5x, which doesn't match the middle term. But if I switch up the signs, I have, if I switch up the signs, I'll have minus 4, positive 3, Now I have my middle term would be 3x minus 8x, which is minus 5x. So I factored this correctly. I also have to factor the denominator. And again, I can just use guess and check. 3x and x multiply to 3x squared. And I can try let's try positive 7 and minus 1, both multiply to negative 7. Now we can check to see if the middle term's correct. The middle term comes from multiplying 3x times 7, which is 21x, minus x is 20x. So I've factored this correctly. Then let's go ahead and divide by, well, let's see if we can factor our divisor. The numerator is already factored, or it's already in, we can't factor it. The denominator, since it has a coefficient of 1 beside the quadratic term, we can factor it by saying what two numbers multiply to 7 and add to 8. So this factors to x plus 7 times x plus 1. Now we can state any restrictions on our variable. We have the restriction, first off, that x cannot be equal to 1/3, because when x is equal to 1/3, 3x minus 1 is equal to 0. We also have that x cannot be negative 7 from this factor, and x cannot be equal to negative 7 from this factor as well, but we've already written down that restriction. Lastly, we have that x cannot be equal to minus 1. So now we can go ahead and change division by this rational expression to multiplication by the reciprocal. Let's write this as 2x plus 3 times x minus 4 divided by 3x minus 1 times x plus 7 times x plus 7 times x plus 1 over 2x plus 3. Now in the denominator, I have a new restriction. I have a restriction that x cannot be equal to negative 3 over 2, because when is 2x plus 3 equal to 0? It's equal to 0 when x is equal to negative 3 over 2. So I have the restriction that x cannot be equal to minus 3 over 2. I have to write that restriction down. I have to write my new restrictions down when I multiply by the reciprocal of this rational expression. Now we can go ahead and we can do we can start simplifying. In my numerator, when I multiply the numerators, I'll have a factor of 2x plus 3. So I can divide out a factor of 2x plus 3. In my numerator, I'll have a factor of x plus 7, and same thing with my denominator, so I can divide out a factor of x plus 7. And I'm left with x minus 4 times x plus 1 over 3x minus 1. And finally, I need to state any restrictions on my variable. So x cannot be equal to, let's see, x cannot be equal to minus 7, minus 3 halves, minus 1, and 1/3. So you can see that I can take this complicated expression that I've written above, and it simplifies reduces to an expression that's quite a bit simpler. In the next video, we'll look at another example where we combine both multiplication of rational expressions and division of rational expressions.